Appreciate you joining us today. We're going to be talking about how to build a text-to-SQL chatbot inside of Hex with LangChain, OpenAI, and of course, Hex itself. So I'm joined today by Jordan East, who is the leader of data engineering and enablement over at Workrise. And I'm Matt. I lead product marketing over here at Hex. So quick agenda for today. Jordan's going to talk through how he first built a chatbot just using OpenAI, how he then went about improving that chatbot with LangChain, and then ultimately deploying that chatbot with Hex so that he could run it on his own data. He'll then demo how he built all of this, as well as at the end, we will send out links for with this app in it so you can play with it yourself. Obviously, you have to swap out your credentials, but then you can use this tool and tinker with it and extend on top of it. But with that, I'll let Jordan go ahead and jump in and start talking about all this.
All right. Thanks, Matt. I'm excited to talk to you guys today about leveraging Hex, OpenAI, and LangChain to build out some text-to-SQL chatbots. Obviously, AI came on the scene in LangChain a couple months ago. I set out to do two things. One, learn more about the technologies involved, but also find ways to apply that to my day-to-day work. So my first project with this was to set out to make a text-to-SQL chatbot. So what I want out of the chatbot, I wanted drop downs for end users to explore different data sets. So I want them to be able to come in, connect to a data warehouse, select a specific database, select a schema, see all the different tables available, and select maybe a table that they want to start asking questions against. And we used Hex and some parameterized SQL to do that. We'll talk about that later in the presentation. I wanted to speed up analytics work. So how good would this tool be at taking basic Q&A against data sets? But not only providing the answer, but providing that base level SQL for that end user to expand on. Maybe they take it and copy it into another IDE and build upon that base level query that was provided by the LLM. And to see what's possible. So, allowing an end user to explore what's possible when they're enabled with natural language from their day-to-day job and applying that to an operational data set or a database. So, SQL Chatbot V1. It took a long time to build. It had quite a bit of code, but I want to talk a little bit about how I approached it. So I wanted, again, to kind of test all the different AI technologies at my disposal. So a couple of those is just going to be ChatGPT, as well as Hex Magic for designing some of the initial notebook. So I set out to use ChatGPT as a coding assistant and really started coding a Python text-to-SQL chatbot from scratch. As many of you all know, if you have explored these tools, and specifically ChatGPT, the knowledge cutoff is still in 2021. And so what I did with V1 is effectively try to build a chatbot built off knowledge that, was 2 years old. LangChain is obviously pretty new and not included in that. And so we really took a pretty base level and I would say hard-coded and rigid approach to building this first version. We did get a working version at the end, but I do want to talk about, some of the challenges that I faced developing it, but also what the outcome was. Was it what I set out to, accomplish in that first slide? And the answer was no. So let's talk about some of the challenges. Again, code length, 170 plus lines of code, and it probably could have continued to grow, handling different errors and functions. It felt like every time I ran the bot, I had to go back and put a new function in to handle something that it did or something that it didn't understand. Speed, so just in terms of when I would put the prompt in and how long it took to understand the prompt, write the SQL query, and provide the SQL query back, was just not as performant as I desired. A lot of the reasons is because all of the different functions and checks that you see here over on the code to the right. And rigid. So in in the interest of getting the initial version to work, I found myself constantly hard coding certain things, such as maybe a table name or column names that it was having trouble, understanding synonyms for. Maybe even if it had an underscore in the column, it was having trouble handling those columns. So I just found myself kind of cutting corners and building hard coded, rigidity into the chatbot. I think this has been increased as of late, but when I did build this a few months ago, if you guys have used ChatGPT 4, there is a limit on how many messages you can send every 3 hours. And so I'm in the process of using it as a coding assistant. We're going back and forth. I'm putting in error messages, etc. And I hit my limit. And so I had about, I want to say, an hour and a half until I could ask it some more questions. And at that point, I had heard of LangChain. I had read a couple, blogs about it, but I hadn't really gone deep into it. And so I decided I was going to spend my hour and a half in timeout researching LangChain and understanding, potential ways I might be able to leverage this framework and technology to improve the initial version of or the initial chatbot that I had built. Yeah, so within 30 minutes, I had a better, more accurate, faster chatbot with 16 lines of code. And so I think this example right here, I think should be a big takeaway in terms of LangChain and what Matt was saying earlier. LangChain is not perfect, but it is a great tool to go out and POC and kind of tinker with some of these new OpenAI models, or frankly, other models, whether it's Anthropic or Llama from Facebook. LangChain supports a lot of different AI technologies as well, so it doesn't have to be OpenAI, to be clear. But yeah, so you could say I was pretty excited building this app in my timeout from ChatGPT. And so let's talk a little bit more about this chatbot version 2. So first, what is LangChain? It's a framework for developing applications powered by LLMs. A couple, points about LangChain. It's data aware, so we can connect a language model to other sources of data. Examples might be, and what we'll show today, a Snowflake DB. It could be a data frame. It could be a PDF. It could be a website, and many more. LangChain is agentic, meaning it allows a language model to interact with its environment. And it's, for me, immediate results was a more accurate and faster chatbot, built with just a few lines of code. So continuing on, what is LangChain, and really kind of providing I think a clear example of what it's doing every time we send a prompt. Let's walk through this example. So a LangChain agent can step through multiple thoughts and actions when given a prompt or question. So if my prompt is maybe against a table called the orders table, and I ask, what is the most recent order? What this chain is going to do is go through and think about these different thoughts and then actions. So first, what do I need for a SQL query to get the most recent order? Well, you can, query the database itself, get all the different tables, get schema names, etc. Okay, you have some table names. Maybe one of those tables is called orders. How do you get the table schema or the columns within the tables? And at this point, the agent or the chain has enough information to go, okay, I think I can query the orders table to return the most recent order. What is the SQL I need to write to do that? And you'll see this exact example when we get to the demo here in a little bit. This is just kind of a visual representation of what happens in this application. So we have Hex kind of as the central point here. It's taking inputs from the user. It's also connected to our Snowflake DB. And we have that little bit of code that we just showed representing the two boxes on the left, LangChain and the OpenAI LLM. And so the user can pick some drop downs, find some tables or data they want to explore. When they're ready, they're going to enter a question or a prompt. LangChain is going to orchestrate the steps for the SQL database chain, leveraging OpenAI. And it's going to provide the SQL code. It's actually going to go write it against the Snowflake DB and provide it back in text to the end user through Hex. Let's talk about a few Hex features before we get into the demo that kind of made this app possible, and frankly, I think added a really nice end user experience. So the first one is input parameters and parameterized SQL. So what you can see here, if you look right in about the middle of this screenshot, you can see select a table, and you can see orders. You can also see sample size next to it at 100. So let's start there. Those are input parameters. Those are a type of input parameter you can use with Hex. There's many other types. For this case, we're using dropdowns. And then what we can do is we can take, you can see that select table and sample size. We can actually take these and reference them in a SQL query down below, which this enables an end user to effectively visually query a database. So you can see down there, we have select all from select database. So that dropdown is not on this screenshot, but it's up further in the app. That's whatever database the end user selected. Select schema, and then select table. So it's actually based on the end user's selections. It's actually designing the SQL query down below, which is an awesome user experience for the end user. It's a great experience for the developer of kind of set and forget. We designed this once, and we can connect different DBs up to it, and it's always going to pull from that information schema. And Snowflake, if you guys are familiar with Snowflake, it's always going to pull from that. And so, again, we'll share the workbook afterwards, but you should be able to just hook this directly up, especially if you're using Snowflake, and immediately, see results. One more is just SQL table display cells. So you'll see when we get to the app, one thing I wanted to add to it is not just the prompting ability and the generating the SQL and SQL to text to SQL, but I wanted, if the user is going to ask good questions, they need a way to explore the data. They need a way to understand what columns are there, maybe what some of the columns hold, so that they can ask better questions. And so we really leverage the SQL table display cells. So what's nice about these is it's not just 10 rows on a display cell on a notebook. It's actually pretty interactive. You can see down at the bottom, you can actually download this as a CSV. You can format it in different ways, adding conditional formatting. You can use the filters dropdown, which we have selected here, and you can actually start filtering that data and doing exploration on it. And so again, wanted to leverage these features to kind of add to the end user experience outside of just the prompting with LangChain and OpenAI. All right, I think it's time for a demo. So let's go into the front end first, and then we'll pop into the back end. I just kind of want to show you guys, so you can take what we review on the back end and apply it to the front end. But this is what the app looks like to the user. So this is where I was saying earlier, where the end user could come in, select different databases, different schemas that they want to explore. We have down here just quick data sample summaries. So we wanted to give a list of tables that are in the database, maybe a list of column names. And of course, we have our full table exploration down here. So before the user inputs any prompts, they have the ability to go look at new tables, et cetera, is what we were just talking about in the last slide. We'll go ahead and run this prompt. So we're just asking a pretty simple question around what is the most recent order in the orders table. And so what you're seeing now is Hex kind of do its first run. So it's going to go populate all these tables, all these dropdowns. And as soon as it's done, it's actually going to run this prompt. Once we run it the first time, the prompts are quite quick. So once we get the first run done, we'll just continue sending new prompts. And I'll show you guys what that looks like here in a bit. We'll let this load and go back over to the back end. So let's walk through how we built this. First, you're obviously going to install some packages that aren't going to be native in your Hex environment. So OpenAI and LangChain and some SQL metadata. This is where we start, and you can see the name of each of these to kind of get an idea of what we're doing. But this is where we start building the front end of the application. So what databases do we have available? We have some markdown here. There's just a markdown cell to kind of tell the user how to use the app. We have the select database, so they can come in, they can pick the F1 database or Snowflake sample. This is where we're, again, using those parameterized SQLs to go grab the schemas. So this is just going to return a list of schemas. This is from a sample Snowflake DB. And all the way down to kind of the meat here. So this is the final query. This is, it's going to look very similar to the screenshot we looked at just a bit ago. But this is kind of the final query that ends up showing on that front end application for you to explore. You can see the data represented here. And let's go down to the meat of the OpenAI and LangChain. So first, this is where we're going to create a connection to Snowflake. When we do share the workbook with you guys, we'll have all of these variables over here in the environment section, I believe. No, variables here. So we'll have this all set up for you guys to where you're just going to come in here and you're going to edit your variables and put in your username, password, account name, etc. But this is the connection stream to kind of create that initial connection to Snowflake. Some more markdown to kind of explain what the app is going to be doing. And here is the meat of the code. So we're doing a few things here. We're importing some LangChain libraries and packages. We're defining the database. So DB equals SQL database is a function from LangChain. Here we're calling engine, which is just what we named the connection right up here. So this is where you kind of call your specific database. In this case, we've actually been playing around with this include tables, and we found it really useful to either save tokens on potentially larger asks or larger tokenized prompts, or if you just want to whittle it down to a table or a set of tables. The other thing we're looking into is actually using some of the drop downs to dynamically call the table in here in this include tables area. LLM, this is where we're just calling our LLM. So we're using OpenAI in this scenario. We set the temperature to 0. We played around with a couple temperatures. We found that this one tended to be the best. This is where we're creating our DB chain. So again, another LangChain function here, SQL database chain is what it's called. You'll be able to easily find this in the LangChain documentation. And a couple other aspects here. One that we found pretty useful is this use query checker. Again, this will be in the LangChain documentation, but it just takes an extra step to confirm that the SQL query that it came up with is accurate and can actually run against the the database. If not, it will return and fail. So, and the last line is this is where we're actually running the DB chain. And what we're doing here is we're calling this user gen prompt as if it was the text that the user provided. And so that user gen prompt is right here with this open text. And lastly, you see this if run the prompt else. So this is just how we take advantage of Hex's built-in input parameters. And so what we have right here is obviously the open text one, and then we have a button one. And so what we named this is run the prompt. And so what this does, it just says, if run the prompt is clicked, run this code. If not, displaying, just display some text, waiting on you to run the prompt, waiting on you to click the button, whatever text you might want to put in there. So let's go back to the front and see what we got. All right, so what is the most recent order in the orders table? This is what the response is going to look like. You get a couple things in this response, and we'll do another one here to kind of show you guys. But you get a couple things in this response. One, which was critical, again, to my original requirements. I didn't want to just have it ask questions and spout out answers. I wanted the actual SQL query so that an end user could go check this or go build upon it. Maybe they want to see the top 10 most recent orders. Well, all you start doing there is changing 5 to 10, right? And you start baby stepping someone who maybe isn't super comfortable with SQL into being comfortable, writing some basic SQL. The other thing you get is the actual result from the SQL query that it ran against the database. So in this case, it looked like it, while we were looking for the most recent order, it said, well, let's go at least get the most 5 recent orders. And then it's going to even take, the result of that, apply your question, which is what is the most recent, and answer your question in natural language using the data. So the most recent order in this database is, August 2nd, 1998. Maybe we can try what is the oldest order. And we'll run it. When you do get this error sometimes if you let it sit for a bit, it just cached the connection. So this is just connecting back to the OpenAI API. And so what we have here is, again, a very similar query. You're going to notice the difference is ascending versus descending. So it took the same approach. Let's see what the oldest 5 records were and print those records. And then let's answer the question in natural language. So the oldest order in the orders table, was January 1st, 1992. So that concludes most of the live demo here. Let's go back to the slides and kind of finish out. So last thing I want to focus on is, what's next? This is obviously a pretty POC format right now. We're trying to understand what kind of queries it's good with. Does it work against, joining multiple tables, which we have had success, but I would say the accuracy at this point is certainly a little bit lower. We found better or more success, hitting a single table or an object or a view. But what are other mediums that we could explore? Is Hex the best medium? Is Slack the best medium? Is a mix of the two maybe something we want to look into? Another thing, as you noticed, there's no memorization or conversational features in our current version. So, want to spend some time learning and understanding how we might store and memorize previous messages and sessions to provide a more conversational experience, as if you were talking to ChatGPT, as most of you might have used at this point. We want to support other data types. So, I'd love to have kind of a dynamic tool where not only could a user select a Snowflake database or a table, etc., but they could upload a CSV, upload a PDF, or call a web page. Those are things that we're looking into, and frankly, LangChain has support for all of these different mediums. They have CSV agents, they have PDF agents and chains, and they have website agents and chains as well. So something that we'll be looking into to kind of build upon this. And the last thing, we've actually started this and seen some success, but when you do get started with LangChain, again, you're going to be able to get started very quickly. But what you're going to notice is, well, hey, I want to go tweak this, or I want to go customize this aspect. And that's kind of the stage we're in now, and using different things like that. Use query checker. Well, there's another, option that you can kind of call in your LLM there that's called prompt. And so you can actually take, so behind the scenes, it's just feeding the prompt that LangChain designed for the SQL chain. So it's very generic, but you can actually take that and customize it into your own. So, hey, you are a Snowflake. So say you're using Snowflake. You are not just a SQL expert, you are a Snowflake SQL expert. And the data you work with is about, for instance, our company, oil and gas staffing. You can start to get it and prompt it to where it might work for your solution or your custom solution a little bit better than it may out of the box. So thank you all so much for your time today. Really enjoyed talking to you about building this chatbot, and excited. Let's do some Q&A next.
All right. Thanks everybody for hanging out for the demo and the walkthrough. I did want to call out at the top. We also have Harrison Chase, joining us here as the founder CEO of LangChain. But I wanted to give Jordan maybe just a chance to talk about how he's already improved on his app. We'd recorded this just a couple weeks ago, but the space is moving so fast that he's made some changes. So, Jordan, you want to kind of talk about any of those changes, and then we'll start moving through the questions that we've been getting throughout the presentation.
Yeah, sounds good. Thanks, Matt. Yeah, thank you all again for joining us today. Excited for some Q&A. But yeah, I wanted to kind of give an update. So we did, as Matt talked, we did record this kind of at the initial stages of this POC. Since then, we were actually able to successfully implement a couple of things that we talked about at the end of the presentation there. So first one, and I think the most impactful one, is we have been able to feed it a custom prompt. And so not only is that prompt customized in terms of working against the Snowflake DB and having some context about our business, but we're actually dynamically feeding it context about the tables and schemas that the user is selecting. And so a couple of the pieces of information that we're feeding it now is column descriptions, column data types, table descriptions. Those are the three that we've started with right now, and saw, I mean, just immediate, improvement in terms of accuracy and performance. Some of the trade-offs with that, and we kind of talked about it, is, as that prompt grows, as that prompt builds, you may start running into some token limits or some token rate limits. Again, maybe Anthropic is a better option for this than what OpenAI is offering from a rate limit issue. So I encourage you to kind of check out different options and see what might work for you. And of course, maybe if you're running into some limits today, wait a couple of weeks and see what happens. That seems to be the speed of things right now. A couple other things that we enabled was allowing a user to select a single table or multiple tables, as well as an entire schema. And so just kind of customizing that experience for the end user. Yeah, and then we were able to start getting conversational and memory in place. Again, immediately start running into rate limit issues and token issues, especially for using GPT-4. But just continuing to see improved accuracy and performance, which is what that's like the end goal of building this, right? We can all build this, and if it's completely inaccurate or it's not something that you can rely on over and over again, how far can you take it? The last thing I'd mention, and I'm sure Harrison can talk a little bit more about this, but we're actually using a new product from LangChain called LangSmith. And what LangSmith allows us to do is trace all the different calls and prompts that are being sent to OpenAI. And what that's allowed us to do is see exactly, what's coming in when we feed maybe column descriptions from a table with 100 columns with massive descriptions, and we blew up our token spend immediately, right? We can see maybe which parts of our prompt that we might be able to reduce or change and still keep similar performance and reduce that token length. And just kind of, again, further understand performance based off the questions that we're asking it. So that's the main updates, Matt, that definitely wanted to give some context for. Happy to answer any questions on these as well as we get into the Q&A.
Yeah, and I'd also think it's worth mentioning, Hex has its own kind of implementation of the natural language to SQL experience we call Hex Magic, which we have some huge updates coming to for our Hex 3.0 launch, which is in about 2 weeks. So stay tuned for that as well if you're interested in experimenting with LLMs on top of your data. Jumping to the questions here, someone asked, did you get any chance to work with Llama 2 7B model with SQL database chain? I found it not quite helpful. Curious if you have experimented with Llama at all, Jordan.
We have not. We are looking into hosting it within our GCP environment, so potentially soon, but we have not. Might have a different answer from Harrison though.
Haven't played around with it too much, but in general, I think we're consistently seeing that like GPT-4 does by far the best. 3.5 is fine, but I think we found Anthropic to be fine as well. But yeah, the models other than that, not quite there, as the question said.
And I'd echo that for the OpenAI side. Fine would be the answer I would give 3.5, especially against maybe like single tables or very simple questions. I mean, it does very well. But GTP4 is far and away, at least accuracy wise, what we've seen work the best.
Next question here. What if your table and column names are cryptic and don't map directly to natural language words like orders? Things with a bunch of underscores, abbreviated words. What's been your experience there, Jordan?
So once I broke out of trying to effectively build a custom chatbot, which was a doomed experience from the start, I would just say LangChain and what they've built and the default prompt that is part of the SQL database chain does a really good job at handling column name synonyms and understanding, I don't know if you noticed on the table I was using, every single one has like an underscore. It's not really named super well. We've had a pretty good experience leveraging that and it understanding those synonyms and being able to and obviously it helps when it's going and querying these tables, right? And then in our first or our most recent iteration, we're actually giving them those column names. And so, yeah, I found that it handles synonyms pretty well. Obviously, I can't guarantee every single table or column name, but we found some good success with it.
And did you say that you're passing in kind of like extra descriptions for tables or columns as well, beyond what's just like in the database?
We are. And I mean, I think that kind of like alludes to another point here where I assume a lot of folks on this call are in the data world and have been working in the data world, but garbage in, garbage out, like, but to another level of, the more we tend to give it, the accuracy tends to shoot up. And so, yeah, we are sending it column descriptions. And so it was nice to be able to kind of out of the box do that. We have spent a lot of time working on column descriptions. I know it's not the most fun thing to do in data engineering, but we do have quite a few of our tables with built out descriptions and stuff like that to leverage.
The larger point here that I might add is it's just all about giving the language model the right context. And so like like the column name provides some context. If the names are like random letters or something, then it's not going to have that context. And so like manually providing descriptions helps. Another thing which is in the same vein that the SQL chain does by default is like show the first 5 rows of the table. So then the language model gets the context of what's actually in the rows. And oftentimes that's even like more helpful than the name of the column, because if you have like percentage, is that like 0.63 or is that 63.0 or something like that? And so showing it that the first 5 rows can give it like more context. Just like, when we're exploring SQL tables, we often kind of like pull up the first 5 rows and we don't look at all of it, but that context is really helpful for seeing what exactly the data is. So it's just all about context, different ways to do that.
Yeah, one other thing I'd add at Hex internally, we were kind of working on redoing some of our DBT models, and we started making some intentional choices about how we name stuff to be more LLM friendly. So yeah, many places to intervene to solve that problem.
I'd just echo that, Matt. We have had a couple interesting discussions with the team of, does data modeling for an LLM look different than data modeling for humans? And I don't know if we have the full answer for you yet, but it's a conversation that we're having and we'll likely be testing out the more we start to understand about how these work.
That'll have to be a whole other webinar session. What has been the accuracy? Another question here. What has been the accuracy of the SQL being generated?
Yeah, so I think it's maybe has a couple different answers. So against an entire schema, we see, I would say, a little bit reduced accuracy. Against a single table, I mean, we've seen 80 to 90% or more in terms of it understanding the query, writing the correct query, and answering the question correctly. Before we started passing it context, as Harrison was mentioning, it was kind of all over the place, to be honest. Again, simple questions like we did in the POC. What's the most recent order? Give me the top 5 orders for May of 1995. Like all of those types of, just general questions. It handled very well. Once we gave it context and column context, we found it to be much more accurate, especially when it was trying to go across schema. So actually trying to understand like which tables it needed to join to answer that question. But I'd very much say, like, at least at this stage, single tables, cutting down that context as much as possible to remove noise, is going to improve that performance. So, implementing that feature to select one table or maybe 2 or 3 tables from an entire schema allows the end user to kind of tighten that realm of what they're actually asking and where the answer might sit. But obviously, for different use cases, that answer might differ.
Yeah, and I'd say for Hex's implementation of this, which again we call Hex Magic, yeah, we've seen similar huge increases. We track kind of the acceptance rate as we provide you the SQL, and then we check, did you actually run it or did you reject what you got back from us? And we've massively improved that acceptance rate, again, largely through broadly the prompt engineering, but what is the context that we can provide? Hex being kind of a notebook format, we have access to kind of all of that context stuff you've previously done inside the notebook in terms of what tables have been already touched. So that can make some of the joins and stuff a lot easier as well. And then again, we have like some really cool stuff coming out in 2 weeks that adds a whole other level of what context we're providing and giving admins some controls as well. So stay tuned for that.
And one question I have on that for you guys is how do you measure kind of like performance? So it sounds like Matt, you guys are doing it in an online manner where you look at like acceptance rate. And so Jordan, is this the same for you? Do you have online metrics? And then for both of you, do you have offline metrics as well? Like if you want to evaluate a change without pushing it to production, how do you get a sense there?
Yeah, well, we launched beta internally a couple of weeks ago. Number 1 on the feature list to add is feedback tracking. So we want to track what questions were answered and what query was generated, which we're using Langsmith, where we hope to use it even more to be able to do that. But 2, we'd like to kind of implement, some sort of feedback system that's user generated, whether it's, a thumbs up, a thumbs down, whatever that may be. At this point, it's in the conceptual stage for us, but it is top of the list because at this point, once we kind of release it out into the wild, like that really should inform, is it working? What's next? What do we need to improve? Things like that. So no, but top of the list.
Yeah. So again, we have the customer kind of feedback mechanism. Before we launch stuff, we have a whole set of questions and our desired expected queries. And so as we're editing what's context in there, we check, like, are we losing out on some amount of accuracy on the completions? So we test it that way all the time. And it's gotten, significantly better just in the past couple of weeks, especially. Cool. It looks like another question here. It looks like you developed most of this project locally. Do you have any tips on creating this app on a cloud environment, especially using Snowflake with other cloud tools?
Great question. I would say I have like 3 versions of this app right now. So it started in Hex. If you are a Hex user or have a Hex account, like, I'd recommend it. It's so easy to get started. You don't have to spin up any environments. You pip install everything, and connecting to Snowflake super easy. So that being said, we effectively copied this into a Slack bot. It really was more approachable than I had thought. It's really easy to create a Slack application and implement that into some Python code. Obviously, to take that to production, you would need to host it. And the third kind of run we did was we built like a bare bones Streamlit app. And so same thing with both the Streamlit and Slack. So obviously with Hex, it is hosted, all that's kind of taken care of. With Slack or Streamlit or some other, custom, what we're using is Google Cloud Engine. And so building a Docker image and hosting it with Google Cloud Engine, we're a pretty big GCP shop. And so we're able to use like Google Groups to manage permissions and access to the app. We're able to use Okta, authentication built into our GCP environment. But that's just us. You definitely want to look at, maybe some things that Snowflake it could offer in terms of hosting. I'm not sure. So for us, we use Hex, and any kind of custom apps that we build outside of Hex, we're using Google Cloud Engine right now to host it.
Do you see any other typical kind of deployments of this stuff, Harrison, that you think are worth calling out?
I think the fun part about, well, I think the fun part about LLMs is a lot of them are accessible behind APIs, so it makes it pretty easy to deploy in a lot of different places. And so some of the things that we're seeing are like, yeah, wherever it's most convenient to have, and again, like a lot of it's about bringing the right context to the LLM. So wherever it's most convenient to have that context is a pretty good place to deploy some of these applications and use these applications. So, the fact that it's so easy to get some of that context in Hex notebooks makes it really easy to just have kind of like applications there. In general, yeah, so especially on like shorter running things where there's like one, maybe two LLM calls, that generally works fine. We see, a bunch of kind of like Vercel edge functions as well for the TypeScript folks out there. The more interesting one that I'd call out is just like longer running agents. When you have like long running tasks, whether it's like they have a very large amount of context and you're running on GPT-4, so it just takes like over 60 seconds to generate it fully or something like that, or where you have a lot of sequences of calls. I don't think that's a super solved problem because a lot of these places have like timeouts on a lot of the edge functions have like timeouts on what you can run in them. So we're spending a little bit of time thinking about that. But generally it's pretty easy to deploy these things most places.
Nice. Have you tested out the possibility to store the metadata of data source and the user question into vector DBs, and then based on similarity and re-ranking to take the most appropriate SQL query?
I can go quickly. Yes, we explored this like early on when frankly I was just kind of exploring different options that LangChain had. The way we did it, Harrison, we used the Snowflake DB like data loader and did that. I'm gonna let Harrison kind of finish this though, because that's about as far as I took it. We didn't go much further than that, but I have been reading on that, and it may end up being a better approach than hitting the DBs directly. I don't know. I'm curious to hear what Harrison thinks.
Well, I think there's a lot of different ways to incorporate vector stores. And so I think like, so if I'm understanding the question correctly, this one sounded like basically store SQL queries, look up similar ones, and then choose the most kind of like similar one and return that. And so I think the pro of that is that ahead of time, like what the, like you can define all the SQL queries that you're going to run. So you're not going to get random ones like drop tables or something like that. It's a good way to be really constrained. The downside is it's really constrained. Like if you get something outside of those, like what are you going to do? Kind of like a combination somewhere in the middle maybe is like you pull in the top 5 most similar, but then you let the LLM generate kind of like its own still. And we've seen that to be this is basically few-shot prompting. We've seen few-shot prompting be really effective when you have more complex kind of like schemas, or you are worried about doing joins or something like that. And that kind of brings in additional context of like what good queries look like. And then, but it doesn't constrain it to just be like those 100 or those however many you defined. The other way to use vector stores, which I think is really interesting and is probably closer to what you were talking about, Jordan, is basically ingest the data, all of the data into a vector store, and then don't even like generate SQL queries, just like do some RAG style vector store lookup. I think that's really effective when you have like text-based things, even like names, like if there's misspellings in names, or like the names, and like dealing with text data is a little bit, can be a little bit tricky. And so having it in the vector store helps. One thing that we've seen help is a combination. Because basically, if you do the pure vector store approach, you lose out on the ability to do some analytical queries, like what's the max of this column or what's the sum of this column. That doesn't work really well. But what we've seen work is you have an agent, and the agent has access to two tools, and one it can run SQL queries on, and then the other can do these vector store lookups. And so basically, if it gets some query that like you need to do something related to text, and this is where the prompt engineering comes into handy, because you got to like say, you normally have to say like, for these columns, like name and job description, like use the vector store lookup. And so then you could do a vector store lookup on some kind of like name or job description semantically, so it basically handles misspellings really well, and that's nice. But then once you have the correct spelling or the correct value of the table or something like that, you then look up the SQL table to get kind of like the full response. So that's a way of like combining the two together, not for like, so I guess I draw the distinction between like combining the two together for showing how to generate SQL, and combining the two together for like fetching different types of actual context. So lots of interesting things to play around there.
Nice.
It's been a common conversation to talk about, the challenges of using LLMs against structured data. And for the last 10, 15 years, we've been talking about trying to structure all of our data so that we can use it. And it's just interesting, kind of almost flipping it on its head. As you guys start to work with some of these technologies, like talking to a PDF is I think, frankly, a lot easier problem than putting an LLM on top of a structured database. And so it's provided some really interesting challenges and just conversations about, what should we be doing with this data, as we mentioned earlier, around preparation and modeling of the data. So,
and I think it's also about the types of questions that you ask. Like if you have a long PDF and it has a bunch of paragraphs, and each paragraph like mentions some number, and then you ask a chatbot to like find the sum of all those numbers, it's probably not going to be that good. And that's like the equivalent of like what it's doing when you're asking like for the sum of a column or the max of a column or something like that. And it's just a different like type of question. It's an analytical type of question as opposed to like a semantic type of question. And so then this also gets back to the UX. Like, what do you want to support for your users? Do you care about being able to do both, or do you care more about one versus the other? And that could very well determine whether you want to use like a vector database, or purely SQL, or some hybrid, something in the middle.
Yeah, there definitely is some deep irony about PDF being easier than tabular data. Another question here, kind of I think a specific interesting question around metadata. Have you tried with Snowflake tables like account usage access history? Example, what tables haven't been used in 30 days? I guess it's a way to kind of scope down like what would be good tables to use.
Yes. So that was, I mentioned earlier, what we've done since is add like column descriptions, table descriptions, column data types. The one that we're working on actually right now is usage, and being able to derive or at least kind of send usage information in the initial prompt so that it can answer those types of questions, or that so it can, I guess, better choose what table that it might go hit for answering a specific question based on the usage of it. So yes, that is definitely a piece of metadata that we're working on, implementing. We have not fully implemented it yet.
Nice. Let's see here. We got a couple minutes left. Do you know how this works when some data is stored as a JSON element in the table? Say they describe a JSON element. Is there a way to know which value to be used in a where clause? It looks like it's more dependent on the column names.
Good question. So we have actually been exploring with kind of an adjacent bot like this for more of like a data modeling or a data analyst perspective. And we've actually had some successful interactions with an LLM that when we feed it the context of that JSON blob, it actually will go write a Snowflake SQL query and using like the flatten functions and actually flatten out the entire table and create a new table for us. That is actually outside. We're testing that outside of LangChain right now. It's actually just hitting OpenAI, the chat completion model. And in that case, it's actually not accessing any of the data or the data within the columns. It's only accessing metadata. And so, what that conversation looks like is actually, like I said, kind of copying and pasting some of that structure of the JSON. And we've seen it successfully, flatten that out. Now, I know that doesn't answer your question. I'm curious, Harrison, if you've seen any use cases around this or have it, handled very well. But my assumption is the way we have our setup right now, hitting those tables directly and asking questions against it. I'm not sure it would derive that very well or do very well against that, and kind of goes back to how do we model this data. But Harrison, what do you have?
Yeah, we haven't seen a ton to deal with JSON column types. I think like my suggestion would probably be to either include some examples of what the column looks like or a description of what the JSON within it looks like, and it could maybe figure it out from there, but haven't played around with it too much.
Another question here, and I know Jordan, your GCP shop, so I'm not sure if you have the answer here, but maybe you might be able to speculate, or Harrison might know. Somebody's asking, conceptually, is it possible to create the chatbot as a function in Snowflake via Snowpark so that the chat is in a form of a select statement via Snowflake?
Sorry, no mute. So that's actually kind of the approach that we're taking with that more like data modeling bot, where it is actually just sitting directly on top of Snowflake. So yes, but not necessarily in this example. And that's kind of like once you get into this, it'll be. I'm curious to see where you guys go with this, because it feels like you start one place and then you fork off here for this and you fork off here for this, and well, this bot is working really good for these use cases, but I want to go test this out. And so that is something that we are looking at right now. I know there's some hosting capabilities, that are coming within Snowflake as well. But in that case, to answer your question, we use all Snowpark. The queries run so fast. And in that case, again, we're not actually giving it the content of the data or of the table, and we're not giving them first name John. All it's seeing is first name, last name, date. And so yes, we have found success using Snowpark to actually execute these queries.
Nice. Sweet. And then as we're kind of wrapping up here, I think a security question is relevant. So somebody's asking here, does text embedding models leak our data when doing in-context learning? Also, when context is passed along with the query, is there a risk of data being leaked to the LLM?
Yeah, it's a tough question, but obviously a really important topic. So building all of this, just first and foremost, we spun up a demo DB. I'd recommend doing the same, especially as you're testing some of these new features. That being said, we use OpenAI. The agreement is pretty clear when using the API that they will not use that data for any training data. They do keep it for a small amount of time for like admin purposes or any kind of like breaking their terms of service. But the terms of service are pretty clear if you're leveraging OpenAI API. I can't talk for any of the other AI technologies. I assume it's a similar one. And Harrison, you might have a different answer here.
Yeah, probably depends on where you're sending what LLM provider you're using, where you're sending the data to. Most of them will not retrain, but will maybe store them for some period, as Jordan said. Some of them can be deployed within your VPC if that is a blocker, and then some of them obviously you can also run locally and deploy yourself. So depends very much on what LLM you're using.
Yeah, and I'd also say, for Hex's implementation of Hex Magic, we don't send any data. It's all metadata stuff. So typically that means, nothing really super dangerous or sensitive is being sent. But definitely something to consider when you are tinkering around your own, building your own tools, making sure you're being responsible about what you are sending over. So we've hit the time limit. There's still a bunch of questions. I'll copy those out, and hopefully we can kind of answer those as part of a follow-up to this. Again, thank you everybody for attending. We will be sending out the code for how to build this, so you can kind of build on what Jordan has created. And we'll also send out a recording if you want to go back and listen to any of this conversation. So thank you everybody, and have a good day.
Thanks, Joe.